Hello, everyone, and welcome to today's webinar. My name is Tepiso, and I am going to be your moderator for the day. I am based in the South African office for the Engineering Institute of Technology, and I will be assisting with today's proceedings. If everyone could please tell me in the chat box if you're able to hear me, and then I will go on to explain how the session will be run, and then we'll be able to welcome today's presenter. Okay, thank you very much. Ladies and gentlemen, to begin, if you could kindly take note of the screen, the slide rather that is up on your screen. Please make sure that you are noting that you're able to turn off the notifications that come through, as well as any messages that might come through during the presentation, and then you'll be able to turn them back off once we have started with today's presentation. We also have a Q&A box or function that is readily available for you should you have any questions. However, I will go on to explain how the question and answer session will go. Okay, now some common questions for you. Please note that you'll receive both a copy of the slides as well as the recording mailed to you within the next 24 to 48 hours by EIT's marketing team. And because today's topic is a technical topic, you'll also be able to redeem a certificate of attendance. What you'd need to do is follow the link or scan the QR code, which will be provided to you at the end of the presentation. Now, if you have any questions relating to today's topic, or if you have questions relating to the Engineering Institute of Technology, please be sure to utilize the Q&A box or the chat box. And if the questions are relating to EIT, I will be able to answer them. However, if they are relating to today's topic, I will have today's host assist with answering those questions. Now, if you're new here, let me tell you a bit more about the Engineering Institute of Technology. We are an engineering specialist offering engineering programs from a professional certificate, which is a 3-month short course, all the way to a Doctor of Engineering, which is the highest academic level you can get to. We are an industry-orientated institution, so we run our programs according to what is going on in the industry. This is why you'll see a lot of program development happening at the institution. We also offer world-class Australian accredited qualifications, meaning that we do have the Australian government's approval to run the programs that we run. We also have international recognition for a select number of programs that we have on offer, that being our advanced diploma, which fall under the Dublin Accord, the Bachelors of Science, which fall under the Sydney Accord, as well as the Masters, which fall under the Washington Accord. And our lecturers are actually industry experienced. They've worked in the field and are now using the knowledge they've gained to teach the learners that we have. Lastly, we have a unique delivery model, meaning that you can study all our programs 100% online, but you can also study a select few on campus. And our campuses are in Australia, Melbourne, Perth, and in Brisbane, and there you can study either a bachelor's or master's, as well as the Doctor of Engineering. Now, I'm not going to go through all of these slides. However, because they'll be mailed, you'll be able to see why students choose to study with the Engineering Institute of Technology. And these are some of the awards that we've actually won, the latest one being in 2024. You'll have access to the slides. And of course, today's topic is going to be external lighting design, an overview and updates of some Australian and New Zealand standards. And today's presenter is going to be Alex Gregory. She's an EIT lecturer, as well as a project manager and coordinator, program runner for the ACOM company. She'll be able to explain a little bit more about herself, and she'll start any presentation. Should you guys have any further questions, as I've mentioned, you can go ahead and leave them in the chat box. I'll be happy to answer them. Alex, without further ado, you can go ahead and take over the slides and start your presentation. Thank you so much for joining us today.
No worries. All right, welcome everyone. Hopefully there is no issues. You can see the slides and myself, and you can hear me fine. So please do let me know in that chat box that we are loud and clear, and we will get started. All right, perfect. So yes, today we will be going through all things external lighting. So specifically, we are looking at 1158 and also 4282, which by the end of today will mean a lot more to you than just some numbers. So what those standards stand for is lighting design in the external context. So specifically, we are looking at roads and public spaces. So the format of today, we're going to go through the relevant standards and regulations that apply to those two spaces. We're going to run through some of the basic terminology that relate to designing in that space. And then we're going to jump specifically into 1158, both the general principles, as well as your lighting design parameters. So a bit more of the meaty context. And lastly, because it does often get brought up in the context of external lighting, we're going to just talk briefly on what obtrusive lighting is, which is covered under 4282. So, touching on standards and regulation. The standards in particular that we are talking about are Australian standards in detail today, but they're just a normal example. There's also very similar international standards. So the British standard we're looking at would be 5489. It is in fact a series that relates to the design of road lighting. You also have TD 501, which again is road lighting design orientated. You have EN 13201, which is your series on road lighting. If you dabble with CIE standards, you would be looking at CIE 115, which is the lighting of roads for motor and pedestrian traffic. EN 12193 relates specifically to sports lighting. And you also have some recommendations within IES and A. So that's just to describe what standards may be applicable in other countries. Here in Australia, we do work with 1158 for roads and public spaces, and as we said, 4282. So the first question is, why do we need standards? Not just in Australia, but in general. Well, there's a few different reasons why we have standards. Obviously, as the name suggests, it sets the minimum standard or the minimum requirements for a particular thing. So in the context of road and pedestrian or public space lighting, first of all, we have a benchmark to determine if something is in fact compliant or not. So we can identify compliance. We can also determine if something is overlit or underlit. So are we over designing or are we under designing? You can also use it as a benchmark when it comes to client or user satisfaction. So if you do in fact have a very dissatisfied client, well, that could relate to the relevance of the standard that you are using. It also gives us something to benchmark when it comes to impacting residents and neighbouring properties. So this specifically relates to our 4282 standard more so, because that gives us a way to measure and to design against impacting adjacent properties. And lastly, if you have an installation that doesn't meet those minimum standard requirements, it could have adverse effects. In the context of lighting, it could mean we have a fear of crime. It could mean that we don't provide safe movement lighting. It could open the case for legal ramifications if someone was to be hurt or trip or fall or be found in an unsafe place due to the adequacy of lighting. And that responsibility comes back to the property owners of a particular place. So for this reason, it is useful to have a set a standard for Australia or for an industry or for a country to which all designs are designed to. So often the question is asked, do you have to comply with standards? And the short answer is, it depends. Standards in and of themselves here in Australia and New Zealand, and it is typically applicable to other countries, are not necessarily mandatory. Standards only become mandatory when they are referenced in legal legislation. So for us, 1158 is not directly referenced in legislation. So therefore, it actually is not a legally binding standard, or what we say, it is not mandatory. But there are ways around that. So although it is not legislated, often your authorities, which could be your governments, your local councils, your transport and infrastructure groups, require you to comply to this standard and this document. So therefore, as they are the clients and the end users, the owners and the operators, they make it a mandatory standard. It could also be something that is called up in specifications. So a project specification may say you must meet 1158. So therefore, contractually, it becomes a mandatory standard. And similarly to local government and councils, you may find that in order to obtain funding for something, such as the new road, a bridge, a tunnel, the funding, which ties back to often government, or it could be private, requires the design of that place to be to a set Australian standard. So, although the short answer is no, it is not legislated, it may still be a requirement and often is through these other avenues. So this slide just provides a breakdown of all the parts of 1158. We call 1158 a series, and that means it is made up of various subparts that all together form that series of standards. So here we have part 0, part 1.1, part 1.2, part 2, 3.1, part 4, and part 5. Now, different parts can have different dates. So you can see here that the latest update was in 2022, and that was for part 1.1. However, some parts have not been updated since 2005. So they do not necessarily get updated as a series, but they do get updated as individual documents. So the way the standard is set out, part 0 is your introduction, your overview. Part 1.1 and 1.2 relate to vehicle lighting, so cars, motorways, roads. Part 2 is your computational procedures behind those designs, so how to calculate the designs. Your part 3.1 is for pedestrian, so category P lighting. Part 4 is purely for pedestrian crossings. And part 5 is purely for tunnels and underpasses. So immediately, if you know that you are looking at the design for a road, you would look at the introduction standard as well as part 1. If you were doing a tunnel, you would look at the introduction section and part 5. So some recent amendments, we mentioned just before that 2022 was the latest that it was updated, and that was for part 1. So part 3.1 in particular was in 2020. And some key changes. The categories names have changed, which we'll run through later. And also, hence today's lecture, there is now a tie between your 4282, which is your obtrusive lighting standard, and your 1158 standard. So you now need to have a report saying you looked at the obtrusive lighting effects of your design. Some D ratings have changed for particular color temperatures. There's been some tweaks to how to calculate your values, and there's been some changes to your requirements for glare. So That is quite detailed. If you're unfamiliar with the standards, it might not mean much to you, but for those who are familiar with the standards, this is included here just so you're aware that as recent as 2024, there has been an amendment. So what does Part 0 contain? It is the introduction to public and road lighting. So it is used for your definitions. It defines all your technical values that are referred to in the later sections. So in particular, you want to pay attention to uniformity because there's different definitions of uniformity. If you are calculating uniformity for V category, which is vehicles, you calculate it as the ratio of the maximum lux value to the minimum value. If you are calculating uniformity for P category being pedestrian, you take your maximum value and you divide it by your average. Now the standard, as we can see from this snip here, also has some basic definitions for the areas. So you can see we have terms such as carriageway, lighting, overhang, so how far a light reaches over onto your calculation plane, mounting height, outreach, the luminaire itself, property lines, poles, etc. So this is just a snip from the standard, but it is useful to go in and, as the name suggests, get an introduction to what you would be reading about in later parts. If we look at part 1.1, this is your vehicle section. The purpose is it specifies the technical performance criteria if you are trying to introduce a lighting system on a road that is expected to have vehicles as traffic. So the focus areas of part 1.1, it gives you your illuminance and luminance values, and we'll discuss the distinction between those two shortly. It sets your uniformity ratios, glare control requirements, and something called UWLR, which we call upward waste light ratio. So essentially, part 1.1 says what you need to do, what you need to meet in order to comply with lighting for a road that is expected to have vehicles. If we look at part 1.2, the purpose is to give practical guidance on how to meet 1.1. So it has more specifics around your design principles and layouts, some installation practices, some maintenance practices, and some operational considerations. So we call this the how standard. Part 1 says what you need to do, and part 2 says how you can do it. So if we look at 1158 part 2, this is the computational procedures. So it provides typically your spacing, so how far you will space apart your calculation points when you are measuring your lux levels. So the examples on the slides here show that for a vehicle category, you might space them 2 meters apart. For car park spacing, 5 meters apart, and for paths, 2 meters apart. You also have modeling software that integrates this information. So if you do use AGI, or you might use Revit, or you might use Dialux, or you might use other software programs, they may already potentially follow the guidelines of 1158 Part 2. So you can see here on some slides some examples of a calculation plane. So this is all these dots here that are spaced on a particular grid. It could be a 2 by 2 meter grid, a 5 by 5 meter grid. Here we have another example just for a non-rectangle. And lastly, you can see here this example for a pathway. So there are lights along the top of the pathway, and then we have calc points along a line on that pathway. And it's those calc points when we're modeling that will measure the lighting levels, and we will check those levels against the standard. Quick question in the chat. Are our Australian standards amendments to the IESNA standards? Those standards in Australia, although they often relate to IES standards or even IEC or British standards, they are not necessarily an amendment. They are still completely independent standards. Often we adopt standards from international standards so that they are very similar, but again, they are considered a standalone standard in itself. Okay, so we've talked about 1.1 and 2. If we have a look at part 3, this is the one that relates to our pedestrian areas. Now, there's only one section 3, so we have both the requirements and how, so the what and the how in the same section. The purpose of 3.1 really is to provide lighting that allows pedestrians to locate themselves and see any hazards that might be around. That's the sole purpose, so it's a big safety aspect. Within 3.1, there also are requirements for luminaire data. There's required levels of performance for every subcategory. So depending if you have a pathway or a car park or a open space, 3.1 will say what illuminance you must hit, what uniformity, what glare, and what ULWR limits. So the same as roads, but obviously different levels because we're dealing with pedestrian spaces, not vehicles. Now, 3.1 does not apply to roads because there's a separate standard for that. It does not apply to wayfinding signage. It does not apply to building security lighting or areas associated with public transport. So those are the exclusions for 1158, part 3.1. So let's jump into some basic terminology. If you've worked in the lighting design space before, a lot of this would be familiar, but for those who haven't, we are starting from the beginning. So first of all, we want to understand what type of lights we might be looking at. So on this slide are 6 different types of lights. You might have seen them already around in your local council or around your house. The first one is incandescent. So you can identify it because it's typically a warm yellow glow. Often fittings are smaller. They're typically historical or decorative. They're not that common anymore. If we look at your fluorescent, these tend to be long tubes. They can be cool or warm light, depending. They also can have a flicker if they're starting up or if they have problems. Your mercury vapor, these are a bluish white light. They're often quite large and round or with an oval fixture. Over time, they can also go a bit green if you've seen that. Metal halide, these are used in your big installations, so car parks and sports field. They're very bright and they have good color rendering. They do, however, take a while to warm up. So if you've ever been the first sport on a sporting field and you need the lights to warm up, they're likely metal halide. Your high pressure sodium, these are most recognizable because they've got a very deep orange or amber color. And lastly, LED. This is now by far the most common installed type of light, whether it's indoors or outdoors. LEDs are small light emitting diode chips. They can be very bright white. You can get them in different colors. And the fixtures can range in size from small to very large with multiple LED panels. Now, why do we have each type? We've mentioned there how to recognize them, but just briefly, your incandescents are rarely used in street lighting because they're not very efficient. Your fluorescents, again, occasionally used for your lower light levels like pedestrian areas or in older installations. Mercury vapor have been used for street lighting, but they're being replaced now with LED. Your metal halide, as we said, are very common in large installations such as your sporting areas and car parks. Your high pressure sodium are typically highways, so high speed vehicle traffic, or as well urban streets. Now low pressure is similar, while your LED again is your most modern form of street lighting. LED is both the most energy efficient and has a very good lifespan. Now, that's the type of lights. You can see them mounted in different ways. Your traditional road lighting or pedestrian pathway is from a pole. So we call those post tops. You could have outreach arms or overhang arms. You could have lights mounted on a wall or a facade. You could have catenary. It's not as common, but say you've got an alleyway for pedestrians, it could have catenary lighting. Now, for public lighting, which is both pedestrians and sort of public spaces, you could also have bollards. They're quite common. You could have lights mounted on columns, on walls, or you could have in-ground uplights, but they don't provide the best lighting values. Question in the chat, back on light types, how do we pick which one we want to use? Most of your installations now by default will be LED. Unless you are sticking with a client or an installation and you want the same type of light installed so that they only keep one type of spares on hand, you could look at the alternatives. But as we said, incandescent, fluorescent, mercury vapor, even so high pressure sodium to a degree are pretty much being phased out. Most of your installations are LED. Okay, so quick overview on light types and mounting. Let's have a look at the general principles from a design perspective. So why do we even bother with road lighting? Cars have headlights. Do we really need it? The National Road Safety Data Hub released statistics saying that 40% of crashes occur at night, despite the fact that only 25% of driving is done during nighttime hours. So, therefore, good lighting is what we use to provide sufficient illumination so that drivers can see and identify hazards in enough time to react. And the number behind that reaction is that if we do have good street lighting, we can reduce those nighttime casualties by about 30%. Now, what hazards could there be? If we have good lighting, we're talking not just about objects and vehicles, but it could be boundaries of the road itself, corners, rises and incline. It could be cyclists on the side of the road, pedestrians crossing the road, structures, curbs, footpaths, light poles themselves holding the lights, or any imperfections that you might see on the road. So those are some of the hazards that we're likely wanting to avoid by implementing road lighting. So general principles. When it comes to general design principles, the design is always from the perspective of the user, so whether that's a car or a person. So you need to consider how your lighting affects the visibility for drivers and for pedestrians. So for major roads, the aim is for a uniformly lit road surface, and you want to highlight any objects or hazards in a silhouette. For your broad road surfaces, so such as your concrete, bitumen, asphalt, we've said you want that to be uniform and you also want it to be bright. The reason for that is you want to reduce any contrast. You need the lighting to compensate for your shadowing. You also need as key inputs information on the lights you plan to use. So it's photometric data. You need to know what the road surface is going to be, and you need to know the geometry of the road. Your surface reflectivity also varies depending on what the material is. Hence, if it's asphalt versus concrete. And that will affect your lighting design because some light might be reflected more with particular materials than others. For minor roads, you want to focus on direct illumination of people, footpaths, and property, so a reverse silhouette. For minor roads as well, we are prioritizing our uniformity and glare as opposed to just having a constant bright surface. So what this means, when we use the term silhouette versus reverse silhouette, think of it as negative contrast and positive contrast. So for a negative contrast, your road surface is brightly lit, such as major roads, so that objects appear as simply dark shapes. It helps as drivers for us to see pedestrians or obstacles and their silhouette. This works best if your lighting is uniform and if you have a reflective road surface, such as this picture down here. So you can see there, you have a very bright uniform road surface and a silhouette of a person. So that's what we focus on for your large roads and also for pedestrian crossings. For your reverse silhouette, your objects are directly lit so that they appear bright against a dark background. So it's the reverse. This way you can see that person or that sign or that feature better as opposed to them being a silhouette. And we do this on your minor roads, on your footpaths or your adjacent areas. So there's a higher focus on glare control and uniformity. So this is why we talk about both luminance and illuminance. So luminance is used for designing road lighting for major roads, while illuminance is used when you're designing for less arterial roads. So we mentioned minor roads, pedestrian crossings, intersections, and ramps. So a question, can anyone tell me in the chat box what they think the difference is between luminance or illuminance? That's all right. Luminance. Luminance is candela per square meter. And it is the amount of light reflected off of the road surface into the driver's eyes. So it's telling us what the driver actually sees. So it's more appropriate when you've got your major roads because major roads are high speed and vehicle heavy. They don't have people crossing major roads. So those type of installations need drivers to detect objects at a distance and in motion. So focusing on luminance gives you a good contrast between objects and the road so they can be seen in that silhouette, gives you consistent visibility across the whole width of your lane, and it can reduce your glare. So we care about luminance for major roads because it's about the driver's perspective, how well the road and obstacles are perceived from that car. Now, on the other side, illuminance is better for minor roads or people, pedestrian areas, category P lighting. It's how much light, as someone in our chat said, falls onto a surface, and it's measured in lux. And it's used where your visual task is closer range and more static, so again, slower speeds. So footpaths, residential streets, pedestrian crossings. Here we want that light to correctly light people and objects, not just their silhouette. Now, a lux level is easy to measure and it's more relevant for pedestrian visibility, property security, and again, your lower speed environments. So let's look at some specific design parameters for our VMP categories. First of all, if you were designing, you would step through a couple of steps as part of your design checklist. Your first question would be asking yourself, what's the purpose of us providing lighting? Is it a road? Is it for pedestrian crossings? Is it just a public space? You then might ask yourself, where could you light that area from? Is there adjacent buildings? Will you be putting in pole tops? Will you be using bollard lighting? You may have existing equipment you need to work with, so perhaps you're just putting in an extension of an existing footpath. Maybe your client already has set pole types and heights and brands that they like to use. You would then assess with the client what type of lighting and category lighting you're proposing relative to the standard. So you would select a category from AS 1158 and proceed with that. And then you might have some other interfacing requirements outside of the standard. Perhaps you do want to look at obtrusive lighting impacts because there's a house next door. Perhaps you want to coordinate with CCTV or other services. But that's your thought process before you start jumping into lighting design software. So this figure, which is figure 2.1, although it's replicated in other standards, is a very good starting point. This shows, just as an example, of road and public spaces and the different types that you might have and what those different lighting categories and subcategories could be. So you can see here we have some sports fields with footpaths. So a cycleway or a footpath could be category PP1 to PP5. You've also got an arterial road, which could have a vehicle category of V1, V2, or V3. You've got some car parks, which are categories PC1 to PC3. You've got some transport interchanges next to that car park, so you might allocate them a pedestrian area of PA1 to PA3. Similarly with shops and malls, civic centres, off-road car parks. You've got some smaller collector roads here, so slower speed, which could be category PR1 to PR5, or a local road, category PR3 to PR5. Another car park over here, which would need a category for parking, PC1 or PC2 or PC3. Some distributor roads, and again, some collector roads. So some V categories for vehicles needed. So it's just an example of in a single precinct, you're going to have a range of lighting categories, whether they're vehicle or pedestrian, and then subcategories, which is your car parks, your PAs, your PCs, your PRs. And each of those subcategories has set lighting design parameters such as illuminance, luminance, glare, uniformity that you need to satisfy. Now, always consider when you're looking at your particular suburb or area or installation and just think about the use of that place at night. That's the key because we don't care about lighting during the day. We need it for nighttime. So as we said, broadly, your lighting design will either fall into lighting for category V, which is roads where there's expected to be vehicles and motorists predominantly. And you could have category V1 to V5, or you could have category P. Now, depending on what category you have, V or P, you then look at section 1 or section 3. So say we had a pedestrian dominant area. So say we had a pedestrian dominant area. We would be looking at part 3.1 because that is for our V lighting. And tables 2.1 to 2.5 list the criteria. So that's where we go, okay, exactly what lux level do we need? We look at those tables. Similarly, table 3.3 to 3.7 gives us further technical parameters. Now, often what's needed to decide the category, so whether it's a car park PC1 or 2 or 3, depends on some things that you need to discuss with your client and agree. So once we have worked all of that out, we have worked out our technical parameters and we're ready to design. So let's take an example for category P. Table 2.5 could give you your outdoor car park requirements, and table 3.7 will give the corresponding parameters. So you can see here your lighting subcategories. For roads, we've said it's PR, which we saw on that big diagram before. For pathways, it's PP. For public activity areas, it's PA. For connecting elements, which could be footpaths, it's PE. And for car parks, it's PC. So for us, we went, yep, we've got a car park, so we need a PC subcategory. Let's have a look at table 2.5. Now, this is just a snip, but the table continues. So in 2.1, as an example, is road reserves. Now, the selection criteria isn't just about where it is. You need to consider the type of activity you could see, whether it's high, medium, or low. The fear of crime, allocate it a rating of high, medium, or low. If there's a need to enhance prestige, and the combination of those things tells you your lighting subcategory, in this case for road reserves. So you might talk to your client and go, actually, we have a common area just outside your building. It's mixed use between cars and people. We think that there's a pretty low amount of people and cyclist activity. It's a pretty safe area, so there's not a high fear of crime. And the building itself is not that important. We don't need to have any need to enhance the prestige of it. So therefore, based on that, we would discuss it with the client and we would allocate for that area a lighting subcategory of PR5. Now there's various tables such as that for all of the different elements we spoke about here, from table 1 to table 2.5. We could then see, this is another example, if we looked at public activity areas. So similar questions, say we had that transport terminal interchange we saw. Maybe we have, when it comes to nighttime vehicles, people coming in and out of an evening. So we have a medium level of fear, medium level to enhance prestige. We might decide on a subcategory of PA2 for that public area. Now, section 3, as we said, once you've picked that subcategory, you jump to section 3 to see what your specific parameters are. Now, in case you see these symbols, I've included the definition on this slide, but things we care about is your illuminance, because it's pedestrian. So average illuminance, point illuminance within the pathway surround, uniformity, vertical illuminance, and glare. So they're our lighting technical parameters, and there will be set values you need to hit for most of those. So this is just one example of 1158 part 3. Say we have a car park. You can see you've got PC1 to PC2, PC3, etc. And up here, after your category, is your target average illuminance, minimum illuminance, uniformity, and verticals. So if you've said, yep, we're going to go with a PC2, you target these lighting technical parameters. If you've got PP1, you would target these. So depending on your road or your pathway or your public area, once you've worked out your subcategory, you then look up your lighting technical parameters. Last step to that would be checking those other two requirements. So we've mentioned glare and we've mentioned UWLR. These are found in table 3.9. And again, you just check what your requirements are so that when you are doing your calculations, you comply with your glare requirements, you comply with your UWLR requirements. A reminder, your UWLR is your upward light ratio. So think of it as the proportion of light from your street lighting luminaire that goes above the horizontal plane into the sky. Now, the whole point of that is to limit light glow at night. It's another reason why we typically use LEDs now as well, because they have very, very low UWLR. Some other considerations you might do. So how high you want to mount your lights, you might want to think about that. And that's the vertical distance between your lights. How many lanes there could be for vehicles, so you'd need to know the layout of the road before you even begun your design. How you're going to arrange or install the works. So, are they going to be on one side of the road? Are they going to be staggered on both sides of the road or the pedestrian path? What spacing will you do between your poles or lights? Will you have an overhang or an outreach on your pole? And what center? And are you going to have any tilts on your light itself, or are they going to be parallel to the ground? So they're sort of, when it comes to designing and modeling your lights, once you know what you're trying to target, some things you might tweak with as part of your design. All right, lastly, we just have a quick slide or two on obtrusive lighting. As I said, obtrusive lighting is tied into now 1158. And what obtrusive lighting is, and it's covered under 4282, is it essentially sets limits on the amount of unwanted outdoor lighting, such as spill light or glare or that sky glow we just spoke about, to limit the effects to people, property, and also the environment. So it's not just people and their houses. Now, this document was updated as recently as 2023. And as part of that, the amendment now includes all living species, which means plants and animals are considered as well. It also is about minimizing spill light and sky glow, so we can see the stars. And it gives some clarification around how to do your calc points. So a good example of this is if you're ever doing lighting designs near the ocean, you might want to consider sea life and turtles and birds and nocturnal animals that could be attracted to a new road or a building that has lighting right adjacent to that seaway. So the standard, as we said, is 4282. And there's a few key points. First of all, the standard defines what obtrusive light is, which is really any light that is causing annoyance, discomfort, distraction, or it reduces visibility to people or plant or animals. It sets technical limits on the amount of light level you can have at a property boundary and also on the facades of buildings. It considers impacts on humans, wildlife, ecosystems, especially sensitive areas. So I mentioned turtles, I mentioned sea life, they're considered a sensitive area or a seaway. Now, your design itself needs to account for environmental zones, buffer areas, and upward light limits. Again, it comes back to sky glow, and we want to reduce sky glow. So again, 4282 is not a mandatory standard, but you may find that you have a client or a council that requires you to comply with it or similar. So briefly, it includes your limit obtrusive light. So it controls the light spill around your property boundaries, again to reduce the nuisance to residents and road users. It considers environmental zones. So generally you'll classify it into one of 4 zones, and each zone has its own limits. It can do a facade-based assessment. So it looks at building facades and sets your property setback lines. You could look at glare and spill thresholds, so setting maximum limits on upward light, spill light, or glare. And that way you can help protect the impact to not only other properties, but you could have other drivers or pedestrians. We now need to consider the ecological impact. So how does it affect wildlife or ecosystems that are adjacent to this lighting? Especially if you've got sensitive habitats, you will need to do risk assessments. You might need to recommend or implement a buffer zone, so a space between the lighting and those sensitive areas. Especially for wildlife, that's a common one. And lastly, design stage evaluation. So as lighting designers, you need to assess your compliance to 4282 and to the previous items we've spoken about throughout your design stages. You can't just look at it at the end. Think of it as an approval gate. So a quick example, say you are designing a beautiful outdoor park. It's near some residential housing and it's a nature reserve. It's got some paths, it's got a car park, it's got some general circulation for people. We might classify that under 4282 as a environmental zone E2. Now, if we do, then we're going to have some requirements we need to check. And we'll do this at every design stage. So we'll make sure that our maximum vertical illuminance is less than 10 lux. We'll make sure our upward light spill is less than 5%. We'll make sure we have glare control using specific low glare optics. We might implement a buffer zone of 15 meters around our reserve. We might change the color temperature of our lights to a warmer light color, being 3000 Kelvin, and maybe implement some motion sensors and timers so we can really reduce the amount of time those lights are on if they're not needed. So that's an example of how you would consider obtrusive lighting under 4282 in your design. So to summarize things we've run through today, we have 1158, which is for your roads and your public or pedestrian lighting designs. First of all, don't forget you need to work out what the space is for, vehicles or pedestrian or both. Allocate it a category. Look up what the technical parameters are required for that category, and then check your other requirements, so your upward light, your glare, and anything else that is referenced under that specific category. When it comes to obtrusive lighting, it is a separate standard. It is 4282, but it is now required to be assessed under 1158. It's often required by the client and councils. And really, it comes down to considering the impact to neighbouring properties, facilities, and wildlife and ecosystems on how your outdoor lighting design at night may impact those things. So hopefully now you've got a better understanding of both 1158 and 4282, but more specifically, the general approach for lighting for vehicles, for pedestrian spaces, and also those lighting impacts from an obtrusive lighting perspective. Thank you.
Thank you very much, Alex. We really do appreciate you being here today. And we are really grateful for this presentation. Because I do know we're short for time, there are a couple of questions in the chat box. I'm well aware that you have been answering some of those throughout your presentation, but any unanswered ones, I think we have the next 6 minutes for you to do so. And then you can possibly just assist with those technical questions. All of them are relating to today's presentation, I can see. And then whilst you're doing that, I'll just put up the QR code as well as the link up on the screen and include it in the chat box for our attendees for the day.
Perfect.
Thank
So I did
you.
see that there's not many questions there. So questions relating on how you pick what wattage LED, it comes down to modeling. So you just need to, once you know what you need to hit, you then need to do a lighting model, typically in software, trialing different lights, different distribution and different wattage to work out which lights satisfy what you need. There's no silver bullet for that one, unfortunately. So for example, if you have 100 watts of each of those lights, you could look more specifically at the lumen output of each of those lights, but you would need to model them. And last question for the day, UGR is not the same as DGI. So DGI is your daylight glare index. UGR is your glare rating. So one relates to daylight, the other just relates to glare in and of itself, which you measure in your lighting model. So consider them different parameters. And that was the only 2 questions, I believe.
Just making sure. Yes, I do believe the others you answered during the presentation regarding the wattage from Kirian Cooper, if I'm not mistaken.
Yes, the 100-watt light of each type. Again, I would suggest looking at lumens and putting it into a model.
Okay, that's great. Thank you so much, Alex. Ladies and gentlemen, up on your screen right now, you do have a slide that shows you which course this topic covers. We have an advanced diploma in illumination engineering and lighting design, as well as an advanced diploma of ESI power systems, Australian and New Zealand standards, as well as the advanced diploma in electrical engineering, and of course some other courses on there. Please note that the first 2 courses are available. However, should you wish to join them, you would need to join the waitlist. I'll provide all relevant links for you guys, should you be interested in applying for those. Okay. So some upcoming courses, these are the programs that are set to run for the remainder of the year. If you are interested in applying for them, I will leave all relevant links for you guys within the chat box, as well as put all the links to contact our course advisor team should you be interested in applying for any of the programs or have questions for the team. Okay, right up on your screen is the certificate of attendance link as well as the QR code. Please make sure to scan. Please make sure to scan the QR code. I am going to leave the link in the chat box as well as pin it for you guys so that you're able to request for your certificate of attendance. Please be advised you need to input your name and surname how you'd like them to appear on the certificate. Please note this process is automated, so we get all the answers from you guys. So you are going to need to input the right names and surnames or last names if you are in a different region. I am in South Africa, so we use surnames instead of last names, but please make sure that you put in your name as well as your surname or your name and your last name so that you're able to have it written or printed out the way that you would like for it to show on the certificate of attendance. The link has been sent in the chat box, and I have as well as pinned it up to the chat. Please make sure to utilize this. And then should you have any further questions, guys, you can go ahead and just ask them. There's like 2 minutes left, but I also see that Alex has also answered a question that came through. Please note that I am going to close the presentation in about 2 minutes. So any further questions stemming from this presentation will have to be noted down for future references. However, thank you so much for your time. Ladies and gentlemen, I will be sure to leave all relevant links relating to this particular webinar. A special thank you to Alexandra. We really do hope to see you on another webinar later on in the year. We will for sure try to get her for you guys, ladies and gentlemen, and then you'll be able to have another masterclass from a principal engineer. I said project manager. She's not just that. She is a principal engineer, ladies and gentlemen. I love to see women in engineering doing amazing things. So please be sure to register for all future webinars, and we will try to get her for you once more. Thank you so much for your time and for attending today's webinar. I will see you on the next one. Thank you so much, everyone.